This is the June 2023 paper 2, calculator paper for the foundation tier. So I'm going to go through this. It is a calculator paper, so make sure you've got a calculator to hand. Question number 1, write 6,184 correct to the nearest 100. So this is your hundreds column, but we always check the next column over, in this case the tens column. 5 and above rounds up, 4 and below rounds down. So the 8 tells me to round up. So this is 6,200 to the nearest 100. For question number 2, write 0.7 as a fraction. Well, this is a 7 in the tenths column. So 7 tenths I can write as 7 tenths, or you can think of that as 7 divided by 10, but 0.7 is 7 over 10, 7 tenths. Question number 3, write 9 metres in centimetres. So we know that 1 metre is 100 centimetres. So therefore 9 metres is 9 times bigger, so that's going to be 900 centimetres. So 900 would be your answer there. Question number 4, simplify 3 times 4t. So if I've got 3 lots of 4t, I'm taking that 4t and multiplying it by 3. So that would just be 12 lots of t. Question number 5. Here is a list of numbers. We've got 20, 40, 60, 80 and 100. One of these numbers is a multiple of 25. Now a multiple is a number in the 25 times table. So multiples of a number are numbers in its times table. So multiples of 25 would be 25, 50, 75, 100, 125 and so on. So which of the numbers above is a multiple of 25? It's going to be 100, because 100 is in the 25 times table. So that's for 1 mark there. Question number 6. Shari has a fair ordinary dice. She rolls the dice once. On the probability scale, mark with a cross the probability that Shari gets the number 7. So we know that if it's a fair ordinary dice, it's going to have the numbers 1, 2, 3, 4, 5, 6. So the probability of getting the number 7 is impossible. Where does that go on my scale? Well, down at this end, 0. That is impossible, and at this end, that is certain. So if I want to mark impossible, it's going to be there at the bottom. On the probability scale, mark with a cross the probability that Shari gets an even number. We can see that an even number would be 2, 4, or 6. Remember, even numbers are numbers in the 2 times table. So the chance of me getting one of those even numbers is 3 out of 6. There's 6 options altogether and 3 of them are even. So the probability of that happening is a half. So we would put our cross in the middle there for that one. Question number 7. Here is a triangle, and the triangle is accurately drawn. Now as soon as they say accurately drawn, that means you can use your ruler and you can use your protractor. There we go, to measure the angles. Okay, so measure the length of AC is this line from A to C. So you're going to get your ruler, pop it there, and make sure that 0 is on one end, and read along until you get to C, and you were allowed anything from, so 9.3 was the correct answer, but they did allow anything from 9.1 up to 9.5. So long as you were in that range, then you're absolutely fine. Measure the size of angle B. Now this is where you're going to need your protractor. So you're going to get that and put that on angle B. Now I would probably turn your paper round at this point, because you're going to need to put your protractor on so that the 0 is against either this line or this line. Okay, so I would turn this round and then I would put my protractor on like this, so that kind of semicircle shape of your protractor, so that this is the 0, and then you're going to measure round until you reach that point there, and that is 106 degrees. But again, you were allowed anything from 104 to 108, so you could be 2 degrees out and still get that mark. Here is a different triangle. QP is equal to QR. Now we normally show that with little lines like that to show that those two sides are the same length. Write down the mathematical name of this triangle. So this is a triangle with two sides the same and one side different, and that is an isosceles triangle. Okay, if all three sides are different, if they're all different, then that's scalene. And if it's right angled like that, if it's got a right angle, then that's obviously a right angled triangle. And then the other one, if all three sides are the same length, then that's an equilateral. There we go. Okay, question number 8. The diagram shows 3 motorway service stations P, Q and R on a map. The map has a scale of 1 centimetre on the map is 4 kilometres in real life. So 1 centimetre on the map is 4 kilometres in real life. Work out the real distance from P to R. So we can see that P to R is 8 add 16, so 24 centimetres on the map. Now I know that 1 centimetre is 4 kilometres. And so 24 centimetres, to work out what that is, well, I've multiplied the number of centimetres by 24. So I also need to multiply the kilometres in real life by 4. And like I said, this is a calculator paper. So 24 times by 4, you can type that in your calculator, and that is 96 kilometres. That would be the real distance from P to R. Question number 9. Here are the first 5 terms of a sequence: 3, 8, 13, 18 and 23. Write down the next term of this sequence. So to get the next number in the sequence, we need to work out what we're going up in. So you can see from 3 to 8 we've gone up by 5. From 8 to 13 we've gone up by 5. From 13 to 18 we've gone up by 5. And from 18 to 23 we've gone up by 5. So we need to go up by another 5, and that would be 28. Write down the ratio of the second term to the fourth term. So the second term is just the second number in the sequence. And the fourth term is 18. So I'm going to write 8 to 18. Now it says give your ratio in its simplest form. So we need to think, what can we divide both sides by? We're looking for a common factor, and they're both in the 2 times table. So I'm going to divide this side by 2, and I'm going to divide this side by 2, and that is 4 to 9. There's nothing else in common, so that is my final answer, 4 to 9. Question number 10. This graph can be used to find the cost of parking a car in a car park for up to 12 hours. Use the graph to find the cost of parking a car for 4 hours. So you're going to get your ruler. Number of hours is down here on the x-axis. So we're going to go to 4, we're going to read up, hit the graph and then go across, and we can see that that corresponds to £6. So for 4 hours that's going to cost us £6. Justin drives into the car park at 8 a.m. in the morning. When he drives out of the car park, he has to pay £9. At what time does he drive out? So let's see. For £9, we're going to go across at 9, which is going to be in between 8 and 10. Again, hit that graph and go down. And we can see that £9 corresponds to 6 hours in the car park. So for 6 hours in the car park, we just need to work out what time is 6 hours after 8 a.m. So 8 a.m. add 6 hours is going to take us, if you think 9, 10, 11, 12, 1, 2 p.m. in the afternoon. So that would be the time that he left, 2 p.m. in the afternoon. You could also write that as 14 0, 0, but either of those were absolutely fine for the mark. Okay, question number 11. The table shows information about the weights of people in a hotel lift. Show that the total weight of the people in the lift is less than 1,200. So for the total weight, I need to work out how much each of these people weighed all added together. So I've got one person here that weighs 40 kilograms, and so that would give me 40 kilograms. Then I've got two people that each weigh 50. So we're going to times that. 2 lots of 50 is 100. Then I've got 4 people that each weigh 60. 60 times 4 is 240. Then I've got 5 people that each weigh 70, and that's 350. I've got 3 people that each weigh 80, which is another 240. And then I've got one person who weighs 90, and that is 90. We're then going to add all of that together. And again, you have got a calculator here. So 40, add 100, add 240, add 350, add 240, add 90 is going to add up to 1,060. So show that the total weight of the people left is less than 1,200. Yes, 1,060 is less than 1,200. So we've done that and we've shown that it is indeed going to be less. And that was for 3 marks. Okay, question number 12. Shape A is reflected in a mirror line to give shape B. On the grid, draw the mirror line. Okay, so if my mirror line was like this, then the shape would be over here. So that's no good. If my mirror line was like this, then the shape would be down here. And that's also no good. So where am I going to need to fold this paper in order for A to land on top of B? And hopefully it makes sense if I do a mirror line like this. Oh, no, there. There we go. So we just want to go, oh, that's not right either. We want to go diagonally through the middle. It's there, isn't it? There we go. Like that. So we want to stay the same distance away. That square is 1 away. That square is 1 away. This square is the same distance away. And this square is the same distance away. So the reflecting line would need, the mirror line would need to actually be diagonal there. So putting your line there is what you need to do. You don't need to go the whole way across, but it does need to be in the right place. Good. Question part B. Alex is asked to reflect shape P in the x-axis. Here's the diagram Alex draws. Explain the mistake that Alex has made. So he's reflected in this line here. And this is actually the y-axis. If he was going to reflect in the x-axis, then we would expect to see that shape down here. It should be down there like that. So he has reflected in the y-axis, not the x-axis, for 1 mark. Question number 13. There are 50 teachers in a school. This is 1/16 of the total number of people in the school. Work out the total number of people in the school. So if you imagine, I've got a bar here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, I've drawn that badly. I'm going to chop that bit off. Like that. There we go. So I've got 16 sections here. So this is 50 people, and that is 1 out of 16. And they're asking you how many people are there all together in the whole school. So 1/16 is equal to 50 teachers. So to get all of the students and people and all of the people in the school, we're just going to do 50 multiplied by 16. So 50 times 16 is going to be 800. And that would be your answer for 2 marks. Question number 14. Packets of sweets are put into boxes. Each packet is a cuboid, 80mm by 60mm by 20mm. Each box is a cuboid, 72 by 48 by 24 centimetres. Work out the greatest number of packets that can be put into each box. Now what's annoying here is that this one is in millimetres and this one is in centimetres. So I'm actually going to change this into centimetres. So instead of saying 80mm, I'm going to say that's 8 centimetres, because we know that 10mm is the same as a centimetre. So that's 8. This one is 6 centimetres and this one is 2 centimetres. And that's going to make it a little bit easier to compare. So first thing I'm going to do is say how many 8s would fit into 72. So how many boxes can we fit going across in that direction? So 72 divided by 8 is 9. So I can make 9 packets fit going across. Next thing I'm going to do is look at 6 and look at 48. So how many 6s can fit going that way? So I'm going to do 48 divided by 6, which is 8. So 8 back. And next I'm going to look at the upward direction. It's 2 tall and I've got 24 centimetres going up. So how many 2s go into 24? 24 divided by 2 is 12. So we can fit 12 packets going up. So 9 across times by 8 back times by 12 up. And again, we can just type that in our calculator. So that's going to give us an answer of 864 packets. Great. 9 times 8 times 12 is 864, and that was for 4 marks. Okay, question number 15. Here is a fair ordinary dice and a fair 8-sided spinner. Charlie throws the dice once and spins the spinner once. Is Charlie more likely to get a number less than 3 on the dice or a number greater than 5 on the spinner? You must show all your workings. So let's work out the probability of each. Let's first look at a number less than 3 on the dice. So that would be a 1 or a 2. So the chance of that happening is 2 of the options out of 6. So a number less than 3 on the dice is 2 of the options out of 6 options altogether. Now let's have a look at the second option, a number greater than 5 on the spinner. So that's going to be 6 or 7 or 8, which is 3 options out of the 8 possible options. And now I want to compare these. Now remember that 2 over 6 is the same as a third. So what's bigger, 1 over 3 or 3 over 8? Now it's tricky because our denominators, our bottom numbers here, are different. So in an ideal world, I'd want to make them the same. So I'm actually going to make them both out of 24. What have I done to this fraction? To make it out of 24, I've times by 3, so I also need to times the top by 3, and that's 9. With this fraction, I've times the bottom by 8, so I also need to times the top by 8, and that's 8 over 24. So this one is bigger, and if it's bigger, it's more likely to happen. So the answer, which one is, so going back to the question, is Charlie more likely to get this or this? Our answer is going to be the spinner is more likely. Okay, question number 16. Paulo drives at an average speed of 56 kilometers an hour for an hour and 45 minutes. Work out the distance that Paulo drives. So I've got my triangle, speed, distance, time, and that's going to help me here. Now you would like to know the distance. So if we cover up the distance and we do the sum that's left behind, that's going to be the speed multiplied by the time. Now the speed is 56 multiplied by the time. Now the time is 1 hour and 45 minutes. Now you might choose to make that 60 minutes for the hour and 45 minutes, which is 105. And you can do that, that's absolutely fine. 56 times 105, but don't forget that's going to get you an answer that's way too big because you've times per minute. So what you'll need to do is when you get that answer, divide by 60 at the end. Okay, so if I've got 56 and I'm timesing that by 105, that's 5,880, but we need to divide that by 60. So dividing that by 60 afterwards is going to get me 98. So 98 is my answer. The other way you can do it is to say that we're going to do the speed, which is 56, times by the time. Now 1 hour 45 is an hour and 3/4, and an hour and 3/4 is 1.75. That's how we write 3/4, 0.75. So you can just do 56 times 1.75, and that would get you straight to your answer of 98. So that's another way of doing it. And you can do it whichever way you find easier, whichever way makes more sense to you. It really doesn't matter. Okay, question number 17. There are 3 cinemas, A, B and C. The mean number of seats per cinema is 380. There are 350 seats in cinema A, 250 seats in cinema B. How many seats are in cinema C? So we know that the mean is when you add them all up and then divide by how many. And we know that there are 3 cinemas. So I know that they've added up all of the total number of seats, divided by the 3 cinemas, and got a mean of 380. So therefore we can work backwards here, and we can do 380 times by 3, and that's going to give me the total number of seats in all of the cinemas. So I'm going to do 380 times 3 is 1,140. So there must be, in all 3 cinemas, 1,140. Now in cinema A and cinema B, I've got 350 and 250. Which is 0, 5 add 5 is 10, so 0 carry the 1, and 3 add 2 add 1 is 6. So I've got 600 seats between A and B. So then I'm going to do 1,140, take away 600, which is 540, and that's how many seats must be in cinema C. So there's my final answer. 540. We knew it needed to add up to 1,140 because when you divide that by 3, you get a mean. And there were 3 cinemas altogether, so that was what they were dividing by when they were dividing by how many. Okay, question 18. Asher buys 180 cans of cola. The cans are sold in packs. There are 12 cans in each pack, and each pack costs £3. Work out the total cost. So 180 cans divided by 12 because there's 12 in each pack. So if I do 180 divided by 12, I get 15. So she must have bought 15 packs. Each pack costs £3. So 15 times by 3 is £45. So 45 is how much she spent on all of the packs. Ethan buys a box of 24 cans of lemonade for £7. There's 330 ml of lemonade in each can. Work out the cost of 100 ml of lemonade. Give your answer correct to the nearest penny. Okay, so 24 cans of lemonade cost £7. So 24 times 330 millilitres is going to give us 7,920 millilitres, which costs us £7. Now, I would like to know how much is in 100 ml. So what have I had to divide that by to get to that? I'm going to need to also divide the price by the same. So 7,920 divided by 100 is going to be 79.2. So I've divided this side by 79.2 to get to 100. So I also need to divide £7, or I'm going to make it 700 pennies divided by 79.2 is going to be 8.83 recurring pence for every 100 mil, and that says give your answer correct to the nearest penny, so that's just going to be 9p to the closest penny, so 9 pence per 100 mil for that one there. Question number 19, 240 people work at a factory. Of these people, 150 have a car, so we can put those 150 people there. 110 have a bicycle, so that's going to be between those two. We know that that needs to make 110 because I've got some people that have a car, don't have a car, but also some people who have a bicycle. And then it says 65 of the people who have a bicycle do not have a car. So 65 of the people who have a bicycle do not have a car. So that's going to go there. 65 people who do not have a car also have a bicycle. There we go. So now we've just got to fill in all of the gaps. I know that if there are 240 people altogether and 150 people have a car, then the rest of the people do not have a car, and that's going to be 90 people. We then know that if this is 65, what do I need to add to 65 to make 90? So 90 take away 65 is 25 there. We also know that these two need to add together to make 110. So 110 take away 65 gives me 45 here. And then we know that these two need to add to make 150. So this one is 105. And that all together, those last four circles, ovals, should add to make 240 if we've done it all correctly. What percentage of the 150 people who have a car, so out of these people, what percentage also have a bicycle? So that's going to be 45 out of 150. And they want that as a percentage. So if you want that as a percentage, you're going to type that in your calculator and then just times it by 100. So 45 out of 150 times by 100 gives me 30. So that is going to be 30% as your answer there. Question number 20, and this is calculator use. So we're going to work out the value of 25 minus root 43.87 all over 6 add 2.1 squared. Now the first thing you want to do is use your calculator and use that fraction button. So that's the first button you want to be pressing, and then we're going to type in just as it is. So fraction button on the numerator, 25 minus the square root of 43.87 all over 6 add 2.1 squared. Now hitting equals, that gives me 1.7652792 So I've typed it in exactly like that. Shouldn't look any different in your calculator. You can do the numerator and denominator separately, but it's easier, I think, just to type it all in one go. Lovely. Then it says work out the value of the reciprocal of 0.625. Now you do have your calculator, so I would probably, if you don't know what this is, type this in your calculator, 0.625, and typing that in your calculator tells you that it is 5/8. The reciprocal of 5/8 is inverting that fraction. So the reciprocal of 3/4 is 4/3. The reciprocal of 2/3 is 3/2. The reciprocal of 4 is 1/4, okay? So those are some examples of reciprocals. Therefore, in this case, the reciprocal of 5/8 is going to be 8/5. And we can just write it like that. It doesn't want it as a decimal, just says what is the reciprocal. So 8/5 is your solution for that one. Quite a tricky first question. Question number 2, good old faithful. Write 60 as the product of its prime factors. So we're going to start with 60 at the top. Two numbers that multiply together to give 60. Now you can choose whatever you like. It's not going to affect your answer. It's going to be the same no matter what. I'm just going to go for 6 and 10. If you get to a prime number, you're going to circle it. So remember, your prime numbers are 2, 3, 5, 7, 11, 13, and so on. So 6, that's 2 times 3, and they're both prime, so we're going to circle those. And 10 is 2 times 5, and they're both prime, so we're going to circle those. So altogether my answer is 2 times 2 times 3 times 5. Sometimes on this question it says give your answer in index form. If it did, you would have to write it as 2 squared times 3 times 5, but as it is, either of those would have got full marks. Absolutely fine, because it didn't say that, so you were okay to give it in either way. Question number 3, there are 48 counters in a bag. There are only red and blue counters in the bag. The number of red to the number of blue is in the ratio 1 to 2. Now I like for ratio to draw them out with the little hangman lines, 1 part on the left, 2 parts on the right. Helen has to work out how many red counters are in the bag. She says there's 24 red in the bag because 1 is half of 2 and 24 is half of 48. Is Helen correct? You must give a reason for your answer. So she's looked at this and said, right, well, I need to divide it by 2. So I'm going to say no. She needed to divide into 3 parts, not 2. So she needed to divide into 3 parts, and then one of them would go here and 2 of them would go there. So actually we need to do 48 divided by 3, which is 16. And so it would be 16 on each of those little lines. So we know that the number of red counters is 16 and the number of blue is 32. Question number 4, and we can see that n, which is an integer, so a whole number we're told here, is between -2 and 5. Now it's greater than -2 or equal to and less than 5. So that means it could be -2, -1, 0, 1, 2, 3 or 4. It can't be 5 because it's not got that equal to on that one up there. So that's all of the solutions there. Write down the greatest possible value of n, so that's going to be 4. Part B, on the number line below, show the inequality -4 is less than or equal to m, which is less than 1. So m is greater than or equal to -4, but less than 1. So I'm going to put circles over those two values. If it's equal to, you can colour that circle in. And then we're going to just join them up with a line, so looking something like that. The 1 is not equal to, it can't actually equal that value. Now, I remember my year 11 teacher saying to me, there's a little man on the line with a pen, and if he can reach it to colour it in, he will do. And so he's reached that value and he's coloured it in because it's equal to. I know it's a bit silly, but that's just how I remember it. So there we go. That's what it needed to look like. And for part C, solve 2/5 g minus 4 is less than 6. So whenever we're solving equations, what we do to one side, we're going to do to the other. The first thing I'm going to do is add 4 to both sides. So 2/5 g is less than 10. 2/5 g is less than 10. Okay, keep whatever symbol is here, keep it the same. Some people like to change it to an equals, but then they forget to change it back. So I would just keep it whatever it is. We've added 4 to get rid of the -4. Okay, now I'm going to times both sides by 5. So 2g is less than 50. And then I'm going to divide both sides by 2. So g is less than 25. And that whole thing has to go on the answer line. You can't just put 25 on the answer line because you need to show that it's less than 25. That is the solution. The less than is important. For 3 marks on that one. Question number 5. Here is a triangle and a rectangle. All measurements are in centimetres. The area of the triangle is 10 centimetres greater than the area of the rectangle. So this, add 10, gets you that one. Work out the value of x. So the area of the triangle, for the area of the triangle, we'll do base times height divided by 2. For the area of the rectangle, base times height. So I know that 8 times 6x divided by 2, that's that and that. 8 times 6x divided by 2 is equal to 5 lots of 4x minus 1, add an extra 10. Because we know that this area has to have 10 added to it in order to be this area. So I've done the area of this, 5 times 4x minus 1, add on the 10 equals the other area. Let's just sort that out now. So I've got 48x over 2 is 20x minus 5, because I'm doing this times this and this times this. Add 10, which becomes 24x is 20x, add 5, because I'm at minus 5 and I'm adding 10, which brings me up to positive 5. What am I now going to do to both sides? Well, let's take 20x away from both sides. So 4x equals 5, and then we can divide by 4. So dividing this side by 4 and dividing this side by 4, x is 5 over 4, but remember again we've got that calculator, so x is 1.25 for that one. That's all we had to do. Work out the value of x. We've worked out the value of x, and that's it for 4 marks. So 1.25 is your answer for that one. Question number 6. Last year, a family recycled 800 kilograms of household waste. 57% of this waste was paper and glass. The weight of paper to the weight of glass was in the ratio 12:7. Calculate the weight of glass the family recycled. So first thing we want to do is work out 57% of 800. Now you absolutely can do 50%, 5%, 1%, 1%, add it together. But the easiest way to do that, given that we've got a calculator, is to do 0.57 times 800 in my calculator. That is going to get me 57% of 800. So 0.57 times 800 is 456, just using my calculator there. Now we've got to take that 456 kilograms, that is paper and glass. So now I want to share it in the ratio 12:7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7. All together, I'm going to take that 456 and divide it. How many piles have I got there all together? It's 19. So 12 add 7, I've got 19 little piles. So 456 divided by 19 tells me that I've got 24 on each of those little lines. Now I could write them all in. I'm probably not going to, no, I've committed now, so I'll do it. 24 on each of those little lines. And that tells you how much is going to be paper and how much is going to be glass. So on the left-hand side, we've got 12 lots of 24. And 12 lots of 24 is going to be 288 kilograms of paper. And on the right-hand side, I've got 7 lots of 24. And 7 lots of 24 is going to be 168 kilograms. And that's your glass. So what did they ask me? They asked calculate the weight of glass the family recycled. That's going to be 168 kilograms for that one. Question number 7. A number D is rounded to 1 decimal place. The result is 12.7. Complete the error interval for D. Rounding to 1 decimal place is the same, rounding to 1 dp, is the same as rounding to the nearest 0.1. Rounding to 1 decimal place is the same as rounding to the nearest 0.1. Now, if you're rounding to the nearest 10, you would go 5 above and 5 below, and that would tell you the maximum and the minimum. If you were rounding to the nearest 100, you'd go 50 above and 50 below, and that would tell you the biggest and the smallest. If you're rounding to the nearest 0.1, half of that is 0.05 and 0.05. So we're going to go 0.05 above, which is going to be 12.75, and 0.05 below, which is 12.65. So half what you're rounding to. If you were rounding to the nearest 1 whole, you do 0.5 above and 0.5 below. So those are your answers. It cannot actually equal that top value. If it did, it would round up, and that's why you don't get the equal to on that top one. You just get the equal to on the lower one. Question number 8. Tamsin buys a house with a value of 150,000. The value of Tamsin's house increases by 4% each year. Rachel buys a house with a value of 160,000. The value of Rachel's house increases by 1.5% each year. At the end of 2 years, whose house has the greater value? You must show how you get your answer. So this is compound interest. For Tamsin, we've got 150,000 and we're timesing that by 1.04 to the power of 2. We want 104%, and as a decimal that's 1.04. So we times it by 1.04 for the first year, and then we times it by 1.04 again. So that's the same as squaring it. This is the number of years up here as the power. So typing that in my calculator, 150,000 times 1.04 to the power of 2 is going to be 162,240. So that's Tamsin's house after 2 years. For Rachel, her house is 160,000 times. Now, if you want 101.5%, that is 1.015 as a decimal. So we're going to times by 1.015 again to the power of 2 because we're just doing it for 2 years. So 160,000 times 1.015 to the power of 2, and that is 164,836. Now it says at the end of the 2 years, whose house has the greater value? You must show how you get your answer. So we're going to say Rachel's house has the greater value after 2 years. You could just put Rachel, that would be absolutely fine. Fabulous. And last but not least, question number 28. Here are 5 graphs. The table shows the equations of these graphs. So we've got lots of different things going on. Now, if you have x squared, that's going to be a quadratic graph, so that makes like a smiley face shape. This one just has the x on its own. It's y equals mx plus c, where m is the gradient and c is the y-intercept, so that's going to be a straight line with a positive gradient crossing at 3. This x cubed tells me that it's a cubic graph, so it's probably going to wiggle like that. This graph is a reciprocal graph. Now that almost, I like to think of it that it looks a bit like a fraction. It's got a top bit and a bottom bit. And again, this one here is also y equals mx plus c, but m is our gradient. And because that gradient, the number in front of the x is minus 2, we know that line's going to be coming down. So using that information, let's have a look which graph makes most sense. So that one, D, is looking like this one. And this one, E, is our wiggly graph, the cubic. So that's looking there like that. And then I've got the quadratic, the first one, that's going to be B. And then I've got my reciprocal graph, C, that's the one that looks a bit like a fraction. It's got a top bit and a bottom bit. And then I've got my negative line there, A, coming down, and that's that one. So B, D, E, C, A, but definitely obviously have a go and don't leave that blank. That's the end of the paper, 80 marks for that. I hope you found that helpful. Let me know if you've got any questions in the comments.